Hi. So let's still in module 1.3 research methods, and we're talking about the third and the last question in this topic, which is how do researchers conduct research? In fact, the methodology the researchers use to conduct research. Now, there are at least five different ways of collecting data. Remember, this is the step three, testing the hypothesis phase or gathering evidence stage. And there are five different ways, at least five different ways that scientists commonly use. And these five different ways are related to the three different objectives of science, which is the DPE, which is the description, prediction, and explanation. So let's talk about these five different methods, but under three different categories. First, we'll talk about three methodologies specific to the objective of description, describing a behavior. Then we'll talk about one methodology specific to prediction. Then we'll talk about one methodology specific to explanation. So coming to the first objective of describing a behavior, the three methodologies, as I said, and these three methodologies are case study, survey method, case study, survey method, and naturalistic observation. Now, keep in mind here, the objective is not about two variables, not about the causal factors underlying the variable, but the objective here is to just describe a behavior or a set of behaviors individually for a given phenomenon. So that it's not an experiment, and you're not trying to find the relationship between two or more variables. You're just trying to find the occurrence of a particular behavior or set of behaviors in a given condition. The first one of such methods is called case study. Now, case study, if you think about it, is observation of behavior from a single individual as a case. Now, if you go to a therapist, he would have an extensive information about a particular case, and he may publish that about describing a particular behavior of a particular condition which this individual is in. Case studies are limited in the sense that the sample size is very small. It's only one individual. And the interviewer, in this case, the clinician or the therapist or the experimenter, will collect data extensively about one individual. It's called case study. The problem with this is that these findings may not be generalizable. Remember that bigger circle of population in the sample and how it is generalized and how you make use statistics to actually make inferences about the population. Well, you can't do that here because there is only one sample. But case studies do provide some basic, extensive information about a particular condition, let's say a disease or a particular field. Then researchers then may adapt further, learn a lot about these case studies and gather some general information, and then develop other studies to actually learn more about it. But case study by itself may not provide more information than just describing a particular behavior. Then again, we're not sure if it generalizes to all the people in general in that particular. Second, second methodology that subjective is to describe the behavior is the survey method. You might have heard about surveys, where people are given surveys and you answer questions, right? Well, in this case, too, the difference here is you have one individual here, and here you have multiple. So it's a real sample. You're collecting data, you're asking the questions, and based on the responses, you have some description of the phenomenon that you're interested in or the behavior you're interested in. So it is better than a case study in the sense that you have multiple subjects. The sample size is bigger here. Again, it is only to describe a behavior. And the questions are also structured here, when the questions in this case study are not really structured. In the survey method, you can actually have a set of questions, put it in a way that you can find some additional information and thought out information or hypothesized connection between different aspects of the behavior. Again, this is just to describe a behavior. This won't help you by itself to find causal connection between any two variables. The third methodology specific to descriptive objective is naturalistic observation. Now, in this case, the individual, in the case study and the survey method, the researcher actually asks the individual questions. In the naturalistic observation, however, the researcher doesn't ask the questions. Instead, the researcher observes the individuals in their natural setting. For example, maybe you're interested in the play behavior of 3-year-olds or the play behavior of 5-year-olds or 3-year-olds. Now you go to that place, you observe the behavior, maybe video record it. Again, keep in mind you need permission to do that. And then you later analyze their behavior objectively and make some observations, right? So you are actually describing the behavior of interest, but you're not asking any questions directly. So all these three methods are limited in the sense that they help you describe the behavior of interest. They differ in what the sample size is. In this case, the sample size may be higher for these two, but they also differ in terms of the kinds of questions that are asked. Survey method is a more structured way of asking questions. Study is more unstructured way of asking questions. Whereas master observation has no question to ask. It's just mere observation of the behavior. Nevertheless, these three methods are valuable to provide some basic information about the behavior and interest that later on scientists can use to actually find additional information and do more to have specific hypotheses that they can test in other studies. So we're talking about the five methodologies categorized in three different objectives. So the first one was description. Then we look at three methodologies. We're going to look at two more now. One under the objective to predict a behavior. The other one under the objective to actually explain a behavior. The commonly utilized methodology to predict a behavior is called the correlational method. In this, you're trying to find the relationship between or the association between two variables. For example, the ACD score and your GPA score, or gender and memory. And it can be more than two variables as well. So in this correlation method, you're basically trying to ask this question: how often do these two variables co-occur? Is there a relationship? Is there a pattern in a way that you can actually predict the value of one? Now, when you conduct research, you come up with um, um, two aspects um, of um, of a value, a statistic called the correlation coefficient. A correlation coefficient is a number with a positive or negative sign before it, and the values range from 0 and 1. So it can be minus 1 to minus 0.75 to minus 0.2 to 0 to plus 0.25 to plus 0.75. The maximum would be 1. So it can range from anywhere from -1 to +1. Now, for our understanding, let's look at the two aspects of this correlation coefficient. There is the strength of the correlation coefficient, and there is a direction of it. Strength is denoted by the actual number, let's say 0.75, and the direction is denoted by the sign before it, which is either positive or negative. If two variables co-occur very often, then you assume that there is a strong relationship between the two variables of interest. In that case, the correlation coefficient value would be closer to 1. 0.99, 0.88, 0.87, 0.9. If they co-occur less often, in other words, they have a weaker relationship. The two variables of interest have a weaker relationship. In that case, the correlation coefficient value would be closer to 0. So it would be like 0.1 or 0.01 or 0.2. So the closer a value is, the correlation coefficient value is to 0, the weaker the relationship is. The closer the value is towards 1, the stronger the relationship between the two variables of interest. That's about the strength of the relationship that you can interpret based on the actual number of the correlation coefficient. So between 0 and 1, which gives us the strength of the relationship. The direction would either be positive or negative. If there is a positive direction, what it means, irrespective of the number, positive direction suggests that as one variable's value increases, there would be an increase in another variable's value as well. For example, if you're looking at the relationship between caffeine and how active you are, again, this is not based on the actual experiment, but let's assume that let's use our common sense to find a relationship, a positive relationship, because the more the caffeine you take, the more active you are. Let's assume so. So the relationship between as the units of caffeine increases on x-axis, then you would see the value of attention also increase on the y-axis. So there would be a steep line. So that would be positive direction. So an example is a plus 0.9 means that there is a strong relationship because the value is close to 1, and it's positive, so the relationship is positive. Negative 0.9 shows there is a strong relationship, but the value is negative. So let's say amount of alcohol you drink and how active you are. The more one drinks, the less active one is. So there is a strong relationship. Again, this is made up. So with increasing the amount of alcohol, the activity or your attention or would decrease. There's strong negative relationship in one, strong positive relationship in the other. Keep in mind, both are strong relationship. It's just the direction is different. So in the negative direction, as the value of X1 increases, the value of X2 decreases. As the alcohol amount increases, the attention decreases. So an example for a strong positive relationship and a strong negative relationship. So in the strong positive relationship, on the x-axis, you see years of education. So 8 years of education, 10, 12, 14, 16, 20. On the y-axis, you see the income, right? And you can see with 8 years of education, the income is somewhere here. With 10 years, the income is actually overall going high. With 12 years, it's increasing. So there's a pattern in this direction. In increased years of education will increase the likelihood of you actually earning more. So study more, go to college. The other example where there's a negative correlation is the x-axis hours of sleep deprived you are, how less you sleep versus how alert you are during the daytime. So if you sleep more, then you're more active. As the number of hours you're deprived of sleep, the less active you are the following day. So you can see the decrease. So this is how a positive correlation looks. This is how a negative correlation goes. And typically these are moderate to strong relationship, given how close these numbers are. But keep in mind, that doesn't mean that years of education is why you're earning more. There could be other factors, and doesn't mean that deprivation of sleep is a cause for alertness. There could be other factors related to it. So correlation does not imply causation. There could be other factors. Just because the two are related, you cannot say one causes the other. One way you can find the cause of a factor of a behavior is by employing another methodology. So we'll go to the last and the third and the last objective, which is explain the behavior, and the methodology is called the experiment. So we can only explain a behavior by finding the causal connection between two variables, which you can do by controlling for that, confounding with the other variable, the third variable that might be responsible for the changes that you see in both these two factors that you're interested in. For example, your ACT score and your GPA. And there could be another factor why these two must be looking as if they are correlated, and that you're hard working, for instance. So if you can control for the confounding variable, then find the relationship between two variables, then you're actually trying to find the cause or explain the behavior. And you can only do that by an experiment. And the variable that you're trying to find, whether it's a cause or not, is called the independent variable. Let's call it X. And the variable that you're finding the effect of the cause on is the outcome or the effect variable, which is the dependent variable. So X is the independent variable and Y is the dependent variable. So let's say you have your research question is to find whether caffeine affects one's math performance. Let's call the X variable caffeine and the Y variable math. So you're trying to see if caffeine is the cause of the math performance. So the Y would be score on a math test you would give to individuals. So X is caffeine, and let's manipulate the level of X, the independent variable, which is caffeine, into two. Level 1 is no caffeine. Level 2 is caffeine. So each variable will have at least two levels, right? Now, let's assume one level has no caffeine, the other one has caffeine. I'm trying to see if this X, which has two levels, no caffeine and caffeine, influences one's math performance. So to do that, you hypothesize that you have manipulated the caffeine condition where you have two levels, no caffeine and caffeine, and you randomly assign one group to the caffeine condition, the other one to the non-caffeine condition. So the caffeine condition will drink a caffeinated drink, maybe the non-caffeine group will drink, let's say, decaffeinated. Again, there are other factors in the real experiment that you needed to take into account, which we're not talking about. I just want to give you a big picture, the general idea of the logic behind the experiment. So you hypothesize that the group one's average math score would be different from the group two's average uh, math performance. So you give them caffeine and decaf to these two groups, and you give them math test and try to see how they do. And you take average of all the math tests for this group, average of all this math tests for this group, and what you're hypothesizing is that these two averages would be different. Or you may also say that the group that has taken caffeine will actually perform better on math tests. The average math score test for this group would be higher than this 50 without caffeine. So what do? You have two conditions. You randomly assign participants to these groups. This is your sample. One is called the experimental group, the caffeine group. The other one is called the control group, which is a no caffeine group. Now, this is an experimental group because the actual condition of interest is here, which is there is some amount of caffeine here in this group because they drink caffeinated drink. This is a control group because there is no value for caffeine. So caffeine group is called the experimental group because there is some value of it. The non-caffeine group is a control group because there is zero value of the actual variable of interest. You just give both the group math test after they consume the beverage, either caffeinated or decaffeinated drink, based on the group they were randomly assigned to. Then give the math test, calculate the individual math scores, then take an average of all these math scores for these two groups, non-caffeinated group and caffeinated group, and see if these two are different and how different they are. Are the average math scores for this group and this group different? If so, how different? Then you use statistics or probability to check if the difference you found between, let's assume, the caffeinated group. Again, this is not a real experiment. This is not the real data. I'm just making things up just so I can explain some constructs to you. Let's assume that there is actually a difference of 20 points on a math test between the average math scores of caffeinated group and decaffeinated. In fact, let's assume on average, caffeinated group performed better than non-caffeinated group. To an extent, their average points were 20 points higher than the non-caffeinated group. Then you use statistics to calculate how likely is that these two groups would have a difference of 20 points if there were no difference between caffeinated and decaffeinated conditions in the population in general. And that likelihood p-value will help you determine whether the difference you see in this experiment is because of chance or if there's a real difference in the population. And that's where the p-value comes in. If it's less than 0.05, so we give a room for 5% chance. So if it is less than 0.05, which is less than 5%, you say that it's too low a percentage, too low of likelihood of this difference to occur in nature if there were no difference between the two. Given that it had occurred, we conclude that there probably is a difference between these two groups, suggesting that the X is the cause of Y. Then you make a conclusion saying yes, no for the research question.